Hello YouTube. Today we're going to be going over a math topic called vectors. And this means it is an object that has magnitude and direction. So some of the topics we're going to be going over today are vector addition, finding the magnitude, and then the dot product. So just a quick demonstration of kind of what we're going to be talking about. This is easily shown on an X and Y plane. So say we have a point here, point A, and we're trying to get to this point called point B. We would, since I'm going from point A to point B, that would be the vector from point A to B, just like that. And so going into things, so we're going to do vector addition first. So say we'll do two-dimensional first. So say I have point A, let's give this 1, 0. And I have point B, let's give this 3, 4. We want to add those. This is our X, this is our Y, this is our X, this is our Y. And so working on these, you want to add your common like terms. So I have both my X's and then both my Y's. And so if you want to pause the video to solve this by yourself, go ahead, but I'm going to continue. So this would be 1 plus 3, and then 0 plus 4. And so that would equal 4, 4. And so that's the vector addition. Now, we can work on a three-dimensional one. So x, y, z. So let's rename these points. Let's do B and D. All right. And so I have this point. Let's do 1, 2, 3, and this point as 3, 2, 1. And so same thing. I like to label my terms, just that way I don't get it mixed up later on. So now that I have those terms labeled, you can kind of implement this equation from the two-dimensional into the three-dimensional. So x plus x is the same, y plus y is the same, comma. Make sure you're doing comma, separating them. But then you have z plus z. And so now that we have our equation, we can go ahead and plug in our values. So 1 plus 3, 2 plus 2, and 3 plus 1. So this would come out to 4, 4, and 4. And so now that we did that, we can go ahead and move on to our next topic, which is finding the magnitude. And so when you're finding the magnitude, you're going to be usually given a vector. So we can just go ahead and name that V. And let's just say this is a two-dimensional vector, so x and y. So let's say this is, let's do 3 and 4. And so when we find the magnitude of a vector, we want to use this equation, x squared plus y squared, all in a square root. So now that we have our equation, we can find the absolute value of a vector, the magnitude, which is the square root, 3 squared plus 4 squared, which is then equal to 9 plus 16, which is equal to 25, which is equal to 5. So the magnitude of vector V is 5. Now, all the time, it's not going to always be perfectly like 5. You know, sometimes you might have square root of 27 or square root of 31. That's okay. That still works as an answer. It's accepted in most calculus. And if it's not, it'll be directed otherwise. So now, we can move on to our second example where we solve a three-coordinate one. And so let's name this vector B. And let's say it has a term of 2, 5, and 1. And so we're going to go about this the same way, but there again, we're just implicating that extra coordinate, which is our z. So this would be x squared plus y squared plus z squared. And then you just want to go ahead and plug in your values. Squared plus 5 squared plus 1 squared, which is then going to be equal to 4 plus 25 plus 1, which is equal to the square root of 30. And in this case, you notice that, we can't take the square root of 30 easily, so we're just going to go ahead and leave it like that as our answer, which is completely fine. So there's that. And then we're going to move on to our next topic, which is the dot product. So the dot product, I like to think of it, everybody is used to, grow up doing 3 times 4 equals 12, and then you bring in the dot when you start using x as a variable, so that's 12. It's multiplication, really, just vector multiplication. That's the way I like to think of it, because it's really the same thing. You have to be careful about your points and which ones are which. So we're going to do two-dimensional first, so x and y, so 2 and 1, and then we could do 1 and 4. And so we're timesing these. Remember, this is your xy, don't forget to label. And so it's going to look like, if we're setting up our equation, x times x, then y times y. And so we can go ahead and plug in our numbers, so 2 times 1, and then 1 times 4. Kind of wrote the 4 sloppy there, but you get the point. So now that we have that, we can now determine that equals 2, 4. It's pretty straightforward. And then we can go ahead and do a 3-dimensional one. So let's do points F to E. So let's have this one be 4, 3, 2. And then this one be 1, 2, 3. We're times these. And so we can go ahead and label x, y, z. X, y, z. And then we can establish our equation. And then once we have our equation, it's just plugging in numbers. So 4 times 1, 3 times 2, and 2 times 3. And that will equal 4, 6, and 6. So that's really the basics of dot product. And why use this? Like, why do we study this? Why do we talk about it? So I made a real world example. This would be better explained as physics. It's used a lot in physics, vectors are, especially in the earlier college lectures, if you take it in college. And so I have 2 examples. Say this is Bill and this is Steve, and they're having a tug of war. And so Bill is pulling with 50 newtons of force, and Steve is only pulling with 30 newtons of force. So we can go ahead and label a positive direction. So let's say going to the left is positive. And so if we were wanting to find the force total, the force net, it would be equal to 50 newtons plus our negative 30 newtons from Steve, because he's pulling to the right, so this is the negative direction. And so our force net would be equal to 20 newtons. This is just one of many ways to implement vectors into real-world examples. It's used a lot over physics and engineering, and then it's even used in 3D modeling, because you deal with the X, Y, and Z coordinates. So just be on the lookout for those, and I hope you enjoyed. And if you have any questions, just leave them down in the comment section, and I'll get back to you as soon as possible. Thank you.